Hello everybody, welcome to our third session. This session on Mastering the Basic Math Facts begins our focus on multiplication by 10. So in our very first session we just kind of overviewed the multiplication process and what we believe about how we learn multiplication facts. In the second session we began with multiplication by 2, and when we talked about multiplying by 2's, we discussed how that is the same as thinking about pairs of objects or doubling objects. So you might think, well, if we started with 2, wouldn't we go on to 3, or when are we going to go back and pick up 0 and 1? So as we work through this progression, the next fact that makes the most sense is multiplying by 10. So hopefully by the end of this session that will make sense to you, and you can decide if this is a direction you would like to pursue maybe the next time or the next year you begin multiplication facts with students, or if you're working with kids throughout the year and you're just trying to decide which facts should I begin with, when should I start, those kind of things. So welcome, and we're going to jump on into our session. Again, we're using the text. I'm sorry for the glare on there, but this is the text by Susan O'Connell and John Sangiovanni that this is all based upon. And one of these should be in your school's professional library, so you can check there and check it out if there are some resources in there that you would like. We are including the digital downloads here in our Edmodo group, but you can certainly also get them by pulling out the book. So let's go ahead and jump right on in, and let's address the biggest question, which is, so why 10 next? Why not 3, or why not 0s or 1s? And the two big pieces here are our number system is based on 10ness, right? It is based upon that we understand as mathematicians and as emerging mathematicians that our base 10 system drives how our numbers work. It isn't necessary to understand other bases, but when we start looking at, say, base 5 or base 2, or we could have a variety of number systems. Ours uses 10 because of the digits and because it just kind of makes sense. And so helping kids understand there are other ways we can work with numbers sometimes can help them, sometimes it can confuse them too, but that's why 10 next, right? It's really the foundation of our number system. We began with 2's because those are pretty comfortable. Kids have doubled things before. It's easy to show 2 groups of 5 or groups of 2. That's pretty easy and pretty comfortable for kids. But when we move to 10's, now we're talking about something that they've been skip counting by probably since kindergarten or even before that. And so what we're trying to do is now leverage students' understanding of 10, and that they can count 10, 20, 30 oftentimes well before they know that 10 times 3 is 30. So we may find ourselves when we're working with kids and their 10s that we might even say things like, oh my gosh, don't you know 10 times 3 is just 10, 20, 30. And at those moments we recognize there's a difference between the understanding the addition and the connection to multiplication. And so as we work through this, hopefully we'll add some tools to our toolbox. You'll probably have some that you would like to add here too. That's great. We certainly welcome your input into these sessions as well. So let's go ahead and look at what our big ideas are for this session. And the first one is the one that we just described, right? Multiplying by 10 is like skip counting by 10, except it shortens the process for that. But the understanding of what's happening when I do something like 6 times 10 is the same as when I skip count 10 6 times, right? Kids need lots of experiences with tens frames to do this. They need experiences with base 10 blocks. And so we'll look at those pieces here as we work through our session today. The second big idea, again, the same as one of the big ideas in our multiplication by 2, is understanding that our number system is really based on patterns, right? And that once I understand certain patterns about 10, that multiplying by 10 is going to end with zeros, and that that is repeated all the time. So at some point a kid will start to recognize, well, when I do 10 times 4, it's just the 4 and a 0 in the end. Oh, that's 40, right? And as long as you have an understanding of 40, then that's comfortable for them. And then finally, the other big idea is the power of the commutative property, right? And understanding that 10 times 3 is a different representation than 3 times 10, and they mean different things, but they have the same value. So once I have those pieces, that makes it much more comfortable for me as a student, and it makes it a lot easier because I have many fewer facts that I need to remember. As we mentioned in the times 2 session, we're always going to bring it back to a literature link. Some of them are more obvious than others. I think 2 of everything was a pretty natural link to multiplying by 2, but now as we move into this session, this is the grouchy ladybug. And so with the grouchy ladybug, you might say, okay, I can kind of see how this fits with 10, but work with us here for a little bit, and I think you'll see how it all comes in together. So in our pre-reading, we're gonna ask some things about the text. Why might this ladybug be grouchy? What might a grouchy ladybug do? What could you expect for that? Just to get kids into the literature piece of it. And while we're reading the text, we might be asking kids to predict some of the next animals, because you see the progression as we read the story. We also want to remember we're not going to get too much into the math as we're reading. We're going to use the literature as a connecting point to come back to later. So we don't want to get too hung up on the math or, hey, look here, let's think about tens here, because now we've kind of broken that stream of thought for kids. So we're just going to enjoy the literature. We're going to have somebody read it to us today, and so I hope you enjoy this. He's very mellow, so let's check this out here in just a second. So let's listen to this reading of The Grouchy Ladybug.
Good evening. I'm Mr. Seven. Yay! I'd like to do a nighttime reading of The Grouchy Ladybug. Nighttime reading is a quieter version of the story. It's a time for you to relax and unwind from your very, very busy day. The Grouchy Ladybug by Eric Carle. The author writes a side note to help you understand the story better. He writes, aphids are very small insects. They suck the juice from leaves, and then the leaves die. Ladybugs eat aphids. That's good for trees, shrubs, other plants that have leaves. To the ladybugs, I have dedicated this book. 3 cheers for them. It was night, and some fireflies danced around the moon. At 5 o'clock in the morning, the sun came up. A friendly ladybug flew in from the left. It saw a leaf with many aphids on it, and decided to have them for breakfast. But just then, a grouchy ladybug flew in from the right. It too saw the aphids and wanted them for breakfast. "Good morning," said the friendly ladybug. "Go away," shouted the grouchy ladybug. "I want those aphids." "We can share them," suggested the friendly ladybug. "No, they're mine, all mine," screamed the grouchy ladybug. "Or do you want to fight me for them?" "If you insist," answered the friendly ladybug sweetly. It looked the other bugs straight in the eye. The grouchy ladybug stepped back. It looked less sure of itself. "Oh, you're not big enough for me to fight," it said. "Then why don't you pick on somebody bigger?" "I'll do that," screeched the grouchy ladybug. "I'll show you." It puffed itself up and flew off. At 6 o'clock, it met a yellow jacket. "Hey, you," said the grouchy ladybug, "wanna fight?" "If you insist," said the yellow jacket, showing its stinger. "You're not big enough," said the grouchy ladybug, and flew off. At 7 o'clock, it met a stag beetle. "Hey, you," said the grouchy ladybug, "wanna fight?" "If you insist," said the stag beetle, opening its jaws. "Oh, you're not big enough," said the grouchy ladybug, and flew off. At 8 o'clock, it came across a praying mantis. "Hey, you," said the grouchy ladybug, "wanna fight?" "If you insist," said the praying mantis, reaching out with its long front legs. "You're not big enough," said the grouchy ladybug, and flew off. At 9 o'clock, it almost flew into a sparrow. "Hey, you," said the grouchy ladybug, "wanna fight?" "If you insist," said the sparrow, opening its sharp beak. "You're not big enough," said the grouchy ladybug, and flew off. At 10 o'clock, it saw a lobster. "Hey, you," said the grouchy ladybug, "wanna fight?" "If you insist," said the lobster, stretching its claws. "You're not big enough," said the grouchy ladybug, and flew off. At 11 o'clock, it bumped into a skunk. "Hey, you," said the grouchy ladybug, "wanna fight?" "You insist," said the skunk, starting to lift its tail. "Oh, you're not big enough," said the grouchy ladybug, and flew off. At 12 noon, it spotted a boa constrictor. "Hey, you," said the grouchy ladybug, "wanna fight?" "If you insist," said the snake, right after lunch. "You're not big enough," said the grouchy ladybug, and flew off. At 1 o'clock, it happened upon a hyena. "Hey, you," said the grouchy ladybug, "wanna fight?" "If you insist," said the hyena, laughing eerily and showing its teeth. "You're not big enough," said the grouchy ladybug, and flew off. At 2 o'clock, it met a gorilla. "Hey, you," said the grouchy ladybug, "wanna fight?" "If you insist," said the gorilla, beating its chest. "Oh, you're not big enough," said the grouchy ladybug, and flew off. At 3 o'clock, it ran into a rhinoceros. "Hey, you," said the grouchy ladybug, "wanna fight?" "If you insist," said the rhinoceros, lowering its horn. "Oh, you're not big enough," said the grouchy ladybug, and flew off. At 4 o'clock, it encountered an elephant. "Hey, you," said the grouchy ladybug, "wanna fight?" "You insist," said the elephant, raising its trunk and showing its big tusk. "Oh, you're not big enough," said the grouchy ladybug, and flew off. At 5 o'clock, it met a whale. "Hey, you," said the grouchy ladybug, "wanna fight?" The whale did not answer at all. "You're not big enough anyway," said the grouchy ladybug, and flew off. At 5:15, the grouchy ladybug said to one of the whale's flippers, So it flew on. At 5:30, the grouchy ladybug said to the whale, "Spin. Hey, you! Wanna fight?" But he got no answer. So it flew on. At 5:45, the grouchy ladybug said to the whale's tail, "Hey, you, wanna fight?" And the whale's tail gave the grouchy ladybug such a slap that it flew across the sea and across the land. At 6:00, the grouchy ladybug arrived right back where it had started from. "Ah, here you are again," said the friendly ladybug. "You must be hungry. There are still some aphids left. You can have them for dinner." "Oh, thank you," said the wet, tired, and hungry ladybug. Soon, all the aphids were gone. "Thank you," said the leaf. "You are welcome," answered both ladybugs, and they went to sleep. The fireflies, who had been sleeping all day, came out to dance around the moon. The end. Good night.
Well, I hope that didn't put anybody to sleep. And invariably, whenever we work this this text in here, somebody says, "Well, why don't we use that for time and things like that?" So you can certainly use the grouchy ladybug for a lot of different math topics, but we're going to choose to use it as a touch point for us to come back and look at multiples of 10. Right? So I'm learning our multiplication facts by 10. So let's think about how we could do that. And we might need to set up with our kids, like, how do you figure out how many spots are on a ladybug, and how would we count those? And so we're going to need some examples of those. We're going to share those with you here in just a second. But let's just imagine a ladybug who on one side has 5 spots on one wing, and on the other wing has 5 more spots. Well, how many spots would that ladybug have? Hopefully our kids can figure out, even if they need to count them, right? But that's going to be 10 spots, right? So in this first activity that is part of our literature link, we're going to give kids a number card, and the card's going to refer to the number of ladybugs on a leaf. So we're establishing that for our math sake here, our ladybugs all have 10 spots, right? And so if I get a 7, that means I have 7 ladybugs on my leaf, and you then can see that I'm practicing 7 groups of 10, right? And so we're going to ask them in this activity how many dots will there be on their leaf, and they're going to need to draw a picture and then write the multiplication sentence. So we're trying to connect that representational, at least, maybe not quite concrete, but at least representational demonstration of the multiplication fact with the abstractness that is the digits that we write down. Kids are going to try it a couple more times. They're going to record their total number of spots for 1 through 10 ladybugs on their board. And then as a group, we're going to talk about, well, how can thinking about these spots, these 10 spots on a ladybug, how can it help me think about multiplying by 10? So we've got our little ladybugs here, and each one of them has 5 spots. So these would be cut out, of course, and then our 0 through 10, so they're pulling the number card that tells them how many ladybugs. They're going to have their little leaf and they draw them out and give them a chance to write out their number sentence as well. So here's the actual recording sheet. Of course, you wouldn't have to use a copy of this. You could certainly make this pretty easily there. So they're going to draw them out, write the multiplication sentence in a structured way, and then explain in writing how would they follow this. So this is where you might have to differentiate a little bit. So if we have some kids that are struggling with the language piece, we don't want to take it away from them, but we might need to think about a way to structure how they're writing about their 10 spots, and how thinking about the 10 spots helps them think about multiplying by 10. So you will know where your kids are in this process. And again, this is just meant to be the large group lesson tied to the literature connection. So we finished the reading and we've done an activity with it. And again, this could be spread out over multiple days, of course. So then we start structuring some questions and leading into our fluency pieces. So these ladybugs, again, in this person's yard happen to each have 10 spots, and she catches 4 of them on one day, 5 on another day, 6 on another day. Well, then how many total spots would she have? Now, in this case, we're getting over 10, right? So we're talking about more than 10 times 10. So in this case, we'd probably be looking at, well, then how do I add up 40 and 50 and 60? But more importantly, is our kids able to get to the 40, the 50, and the 60? So I'm looking at how different kids are doing on this kind of task, who needs a partner to work with, who is good on doing this on their own, who maybe is jumping right to the multiplication sentence, who has already got it and needs a little bit more of an accelerated pace. So an activity that we'll call looking for patterns. Now we're getting a little bit more abstract, using our base 10 blocks, preferably our base 10 blocks, but you certainly could use the cutout versions here. So we have some paper versions that you could certainly make if you don't have base 10 blocks, though I think most schools have adequate supplies of base 10 blocks. They're not always in your classroom, but you can usually find them around the school. So each pair of students gets their base 10 block set. They're going to get rods to find the products for times 10 facts, right? And then look for the patterns they would see. So the sheet itself is going to look very much like the sheet we had when we did our times 2 facts, right? So we're really just trying to give them the representation, the concreteness, and then take it over here to the abstract. So what we really want kids to be looking for are the patterns. So you remember some of the questions we asked with the times 2 facts. We were looking at, what do you notice about the numbers, and all those same questions we would have asked with the multiplying by 2, we would ask with multiplying by 10. We also know that different kids are going to arrive at different times, right? They're going to be ready for things at different moments. So we had these little mini ladybugs that are the same as the bigger ones we looked at before, but we might have some kids who need to use a hundreds chart, right? And they may, so they take their ladybugs and their hundreds chart, and they're going to put the ladybug on the 100 chart to show the total number of spots. So some kids might need to count them aloud, and they might, we're going to ask some questions, sorry, like, what do you notice about the total number of spots and the total number of ladybugs? So if I have 2 ladybugs and it happens to be 20 spots, what do you notice about how those two connect? So we've got a hundreds chart. You can see you can imagine the ladybugs being on the chart and where they would all begin to fall, right? So you'd end up with one ladybug, I've got 10, 2 ladybugs, I've got 20, 3 ladybugs, I've got 30. So the pattern of 10, 20, 30, 40, 50, again, another chance to bring that out with the kids. A good chance to chart it out as well, of course. Another way that we connect with our multiplication by tens is by talking about money, right? Kids are generally at least motivated by money. In today's world, they don't have as much connection to things like dimes as maybe some of us as adults had growing up. But then again, when we were their age, we probably didn't have that much connection to the change anyway. So at some point, we've got to teach what a nickel, a dime, and a quarter is. And so this is a good chance to both kind of re-emphasize how our coins work and how they relate to the whole of a dollar. And we can also lay it out and think about, well, if 1 dime is worth 10 cents, well, how many dimes do I need for 20 cents? And looking for that pattern here. So as we think about this, we're going to think about it in terms of a function chart, which we might refer to as an input-output chart, as a good visual for this. So you see that there on the worksheet And so we ask questions like, well, if Alex had 6 dimes, well, how many cents did he have? How many pennies did he have, right? And then we're going to start connecting it to other examples. So we're looking at multiple representations, right? So now we've talked about money. Let's expand it to, how about rows? So if I have 4 rows and 10 chairs in every row, if I have 6 packs of pencils and there's 10 in each pack, and we don't want kids to ever get the idea that the only place multiplication facts live is in one representation. So connections to money, connections to how we set up our room, connections to things we might buy in a store. And all those are meant to get kids comfortable with the facts, right? And not expecting them to simply memorize the facts, but really to build fluency. So as they're building the fluency, then they need some time to start making them more automatic. And so the games were a good place to bridge the I guess we call maybe the large group and the guided practice. Games become more independent practice or small group practice, right? So, and they're also more motivating and more fun. So we talked about that with our ×2 facts. So let's look at what some of those could be for multiplying by 10. So this one is called top tens. So students that are going to get in pairs, and they're each going to get a number cube, and it could be a 1 to 6 number cube. It could also be a number cube that has more facts than that on it if they're ready for that. So they're going to roll it, they're going to multiply by 10, they're going to record it on their sheet, and after 3 rolls they find their sum, and the person with the largest sum wins. Or you could play kind of a golf strategy, right? You could say the person with the smallest sum wins. So the pairs are getting this practice. You could certainly rotate. Seen a person use this where the winner of round 1 moved up a desk, kind of in a bunco kind of strategy. You get to move up if you win, and the people who lose slide down, and you get all this movement going on. Again, that was the case where most everybody was working on the same fact. How about a second activity here? This one being called Keep It, Toss It. The kids would use a spinner. Oops, I thought I had the spinner on there. But they would use a spinner, and they would multiply the result by 10. So they're gonna, same way that we would use a die, right? So just a different feel to it. Now the trick with this one, and Keep It, Toss It, is you have to decide if I like it and I'm going to keep keep the number, or I'm going to get rid of it. The trick is you only get to keep 5 of your answers, and you have to toss 5 of your answers. So you only get to spin 10 times. And the trick is you want to get as many, or you want your sum to be as great as possible. So if I spin the spinner and I get a 4, okay, so 4 times 10 is 40. I write down the 40. I got to decide, do I think I can do better than that? Do I want to toss it, or do I want to keep it? And so it becomes a little bit of strategy here, and what kind of values do I want to keep? And you could certainly introduce the rule of you can only use the same value twice. So if a person keeps getting 4 times 10, you force them to practice other facts. And again, just another way to make it more engaging and to build that automaticity. You can encourage kids to be quick with it, although speed should only be based on me getting better today for myself. So another example being these mini math fact rings. So this is meant to be very quick practice. So kids are going to write the numbers in whatever order they would like around the ring here. So I may put on here, here's my 1, here's my 2. You could certainly tell kids they can only use certain values, right? So 1, 2, 3, 4, 6 there, put a 9 over here, a 10 in here, put, what I forget, 3, 4, 5, 5, 6, 7, and I need an 8, right? So in whatever order I would like, right? I put them around the sections of the ring, and then you could do this with a spinner, although the directions on this are just to record. So 10 times 6 becomes 60. I've certainly seen the strategy used where I might make the ring, and then I give the ring to my partner, and I do their ring, they do my ring, and we see who can get their ring done the fastest. So ways to make it a little bit more engaging, a little more maybe competitive. Maybe competitive is not the right word, but another piece we want our kids to do, and another way to help build both fluency and conceptual understanding, is by connecting the multiplication facts to what they look like in an array, right? So we give some kids some centimeter grid paper like you see here on your screen. They're going to pull a fact card and then they create the area model for that fact. So let's say that I pull 4 times 10, right? So as I pull that 4 times 10, I now need to make that out of my grid paper. And here we are, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I apologize, that isn't exactly 10. I think it is, but it's a little tricky here on the screen to see. And then I'm going to record on here, right? 4 times 10. Some kids might need to write the numbers in each box. And I might write, I also know 4 times 10 is represented by 40. They could then cut these out, make an area model, right? If I'm using fact cards for this, I'm filling these in as I pull the fact cards. So there's a little bit of strategy in terms of trying to use up all the space. There are also some thoughts about you could do this with a rolling a die if you don't want to use the fact card. So lots of different ways to get kids involved in their facts. We've probably all done partner fact card practice. So by using the fact cards, and again these are all in the downloadables, and you probably have your own already anyway. But when kids should be working on the fact card that they are personally trying to build fluency and automaticity with. So I might still be working on my 2s and you might be working on your 10s. It doesn't really matter, right? We can still practice back and forth. We can practice with a partner. As we remind ourselves here at the bottom, you want to add in the 10s facts with our 2s, not just take out the 2s and start the 10s, because then we're not getting that continued practice. Checking for progress. There's a couple tools here in this resource that get into checking for progress with multiplying and dividing by 10s. So you see it in a variety of ways here. You see the just multiplication facts, just division facts. There's also a mixed review that mixes up the multiplication and the division facts to see how we're doing with both of those. However, as the teacher, what I need to do is make sure I'm keeping track of who is on which facts, and that I, the student, am keeping track of, on this day, how many facts did I get correct, right? So if I'm using this sheet, did I get all 25 right? Did I get 10 right? It doesn't necessarily mean you have to use this sheet, but as a student, I want to try to improve each time. So you see here some of those examples of a times 10 mixed review, and then just a straight times 10 fact. So for some kids, we want to probably narrow it down and just do the times 10 piece. Maybe once I graduate out of that, then I'm moving into mixed review, so now I'm picking up my times 2 facts. You could certainly go back and forth between the two, but you need to know your kids and what they're comfortable with, because you don't want to build math anxiety through doing this either. And ultimately we're going to come back to division, right? So now we come back to that same activity we started with. So now instead of knowing there are 8 ladybugs and they each have 10 spots, now we know that we've got 80 spots, right, or 80 dots, right? So if I know I have 80 dots, let me see if I can represent that. Now, how many ladybugs would that be, and how do I write that as a number sentence? What does 80 divided by 8, or 80 divided by 10 in this case, look like? Well, 80 divided by 10 looks like this, so how can I read that? Well, what times 10 gives me 80 is one way to think about that. And again, using what I know about multiplication to learn my division. Thinking about division with manipulatives. As we get into division, we want to connect back to what kids know about, or I should say, familiar manipulatives, right? So if kids have used base 10 blocks a lot, this becomes pretty comfortable. If they haven't, this is a little bit more, it certainly can be comfortable, but it takes a little bit more work. So you need to know your kids, you need to know their experiences. But let's take a look at using our base 10 blocks and thinking about some of these pieces, like if I'm given 4 rods, well, how is that like multiplying? How is it like division? So ultimately, we're looking at that last question, right? So if I have 40 and there are 10 in each row, well, how many rows would there be? So let's take a look at what that would look like using a virtual manipulative because I can't really give you a hands-on manipulative right here. So this is the Glencoe site. I think we used it before, but the site is there on our PowerPoint slide too. So if you like this, you can certainly use it. It works great with smart boards and stuff like that. So if I have 4 rows here, so let me kind of get those a little bit more lined up than they are. If I have 4 rows, and I know there's 10 in each row, well then I might have written that in the past, right, as, let's see if I will cooperate to let me do this. It might have let me in the past think about that as 4 times 10 has a value of 40, right? But let's think in reverse here. If what I know is that I have 40 objects, right? Because I've counted these up and I know that's 10, that's 20, that's 30, that's 40. If I have 40 objects and I decide, you know what? I know there are going to be 10 in each one of those. So I'm going to divide that into groups of 10. So I'm going to take this whole of 40 and I'm going to divide it into groups of 10. What does that give me? Well, that gives me my 4 rows, right? So writing it out like this, can you see, I mean, from a kid's point of view, that how abstract this is without some words like maybe seats, right? These are 40 seats. Sorry for my messy writing on here, but and these are 10 seats in a row or per row. In a row. And that would then tell me, you know, how many rows is that? So using the virtual manipulative, what I can do here, I'm going to get rid of that typing there, I can link these two together, right? So I can start with the 40 and say, all right, so this is more realistic in terms of having the 40, right? So here are my, ooh, I jumped really fast, sorry. Here are my 40 seats. Well, what kind of groups can those come in? They could certainly come in groups of 4. We're going to look at that later, right, when we do division by 4. But when I'm looking at these generally, right, they come in groups of 10. So I'm saying, well, how many of these groups of 10 do I have there? So let me jump back over here and grab, well, if I broke that out, I would again have my 1, 2, 3, 4. Those two are the same, right? And so this becomes 40 broken into groups of 10 tells me how many rows I have, and that becomes this. So it's great for you or I to do that. It's much more powerful, of course, when the kids do it. And the beauty of a virtual manipulative or the base 10 blocks is we can do this again and again and again and again and again with little work. We can just keep presenting new manipulatives. A key part, I shouldn't say the key part, but a key part of this, though, is right here. We've got to connect what the manipulative is showing with what the numbers look like. Kids don't generally naturally make this connection, so they may see the virtual manipulative as one thing and the numbers as something different, and so it takes us as the teacher to usually make that connection for them. So beware of that as you break into the manipulatives if you haven't used them a whole lot already, or if this just happens to be a new use of them for your kids. I think this is one final activity here for connection to division. So this one's kind of fun. I've seen a number of kids really enjoy this. So they're going to write the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the boxes here. So they can write a number 6 times if they want to. If I just want to put 4 in here a bunch of times, I can put 4, 4, 4. You know, if I just happen to know 4 times that 40 divided by 10 is 4, I'm going to use that a bunch of times, or I just feel that's my lucky number, I can do that. And then I'm going to fill in the boxes. As a teacher, you can certainly tell kids they can only use each number a certain number of times. But so this is giving them a little bit of choice in the process, right? So they're going to write in all the numbers that they would like to put in here. And then we're going to use the spinner below, and they are going to spin, right? And their objective is to cross out all the numbers that they chose. So if I do this, I might hit that 4 in the first try, right? And so when I get that 4, I get to cross it out and say, yay, there's 1, right? And then I spin it again and I get 10. So I do 10 divided by 10. Well, that gets rid of one of my 1s up here, so I can cross that out. And the first person to cross out all their numbers, you and I, as the teachers, know they're going to get a lot of practice with a bunch of facts that when they spin it, they either already used it or they didn't put it on their list. So they're practicing all their facts, whether they realize it perhaps or not. And it gives them a nice little station activity kind of thing to do. And again, this is one of those things that they could do while we're in the midst of studying tens, but they could also do this much later if they come into knowing their tens a little later than some of their peers. And that, my friends, brings us to the end of this session. So my hope is always that the professional development is useful to you. So we want you to make the to-do task here something that is useful for you. We had an assignment back with the initial one. We had a little bit of an assignment with the times 2 facts. So right now with this times 10 one, I'm not asking you to do anything except if there are tools or resources that you use specifically related to multiplying by 10, I'm going to ask you to share those in our Edmodo group, or you can submit them with the assignment. In order that I can check you off for this particular session, if you will just click the turn in button and post, I watched the video, and again, if you have a resource that you could share there, that would be awesome as well. So we'll see you for our next session, and that is multiplying by 5. So thank you again for your time, and we look forward to seeing you next time.